So to recap from yesterday, because I feel like we got to the main point of the lesson, when everyone was really not focused and we were all trying to go to the next class. So to recap, we practice, expanding and then foiling that we should know how to do from unit 6. And we also practice factoring a bit. What we noticed, or what you should have noticed, is that for every single one of these, the factored form had the same exact parentheses. So when it's the same exact set of parentheses, you could write it like this, as 1 parenthesis squared. Because what do exponents tell you to do? Multiply the base by itself, however many times the exponent is. So that you can write it as that. And the reason why that's important is because in the next thing you're going to learn, we're going to want it to be a perfect square. And if it's not a perfect square, we're going to show you how to make it a perfect square. And then that's another way of solving. So this unit is all about solving quadratics. We covered factoring. Now we're going to cover what's called completing the square. So for me, personally, I like memorizing fewer things. I know it's a perfect square trinomial if when I factor it, it looks like this. There's another way to know just from looking at the trinomial and not factoring, but I feel like that's just too many random things to memorize. But in case you're interested, it is this from the first activity we did yesterday. So if it's a perfect square trinomial, it's in this form, where it's x squared plus 2nx plus n squared, where x would be like the first thing in the parentheses and n is the second. So in each of these, and I color coded it, in each of these, they all start with x squared, so x was first, right? So no big surprise there. But then they all end in n squared. So like the second number, look at it. What's -7 squared? Positive 49, and that's what we got in the standard form. What's 1 squared? 1. What's 4 squared? 16. So that was a pattern. And then that middle term was always 2 times n, and then x was already there. So like if you do 2 times the second number, what's 2 times -7? -14, and that was in our answer. What's 2 times 1? And 2 times 4. So it's a pattern. So you could memorize that, but again, I feel like that's a little random to memorize. I just factor it and see if it's a perfect square or not. All right, so look at the back side of that page where it talks about 2 different methods, Hans and Jada's. So they solved the same equation with 2 different methods. Hans is what we already know how to do, so let's define each step. The first step is just what's given to us. Great practice for geometry, and the test has a little bit of where you name the steps, what's going on in each one. How did they go from the first step to the second step? They broke up the square, so they expanded it into where it looks like x minus 6 times x minus 6, because usually that's what you have to do before you FOIL it, right? So going from this step to the next one, they FOILed it or multiplied, whatever you want to call it. And that's how they went from factor to standard form. And then we learned that if we want to solve by factoring, that we have to set the equation equal to 0. So that's the difference from here to here. So set, and I don't really have room, so I'm just going to put equation like that. Set equation equal to 0. All right, because how do you make the 25 0? Subtracting it cancels it, and then whatever you do on one side of the equal sign. So then 36 minus the 25 is 11. That's what they did. They set the equation equal to 0. They factored which what's the only way we know how to factor a trinomial? The diamond method. So they thought what numbers multiply to 11 but add to -12? What are they? There's only two numbers that multiply to 11. Good, and then if they add to a negative, makes them both negative. So that's usually how I think about it. What multiplies to the top, and then if I need to play around with the symbols, now it works for the whole thing. So that's how they factored it. Do you guys know what they did to go from here to here? From their factored form to now x equals 11 and x equals 1. Sorry, what was that? I didn't hear. Okay. So what do you call that? What did they do? How do they know that x equals 11? Okay, so plugging it into the equation, because you remember that property that if you have two things that multiply to give you 0, one of them must be 0. So what they did is they set each factor equal to 0 and solved for x. I'll just kind of summarize that by the 0 product property. So what we just said, like if you multiply to get 0, one of the numbers must be 0. So that's why we do this here. Because what minus 11 gives me 0? 11. And what minus 1 would give me 0? So that's why most of the time there's two answers, because usually there's two ways to get the factors, or at least one of the factors to 0. So no, it's the 0 product property. Use the name. I can tell you when your constructed response for this unit, you're going to want to know it by name or be able to explain it. So yeah, questions on Han's method. All right, now look at Jada's method. Does Jada have as many steps? No. So that's why sometimes you might consider solving it, and I don't know what the proper name is for it, but we could say by square roots. All right, so this is what we were given for Jada's, same problem we were given for Hans, except for what is opposite of squaring something? So she just took the square root of both sides, which then cancels out the square on the left side. I just get x minus 6. On the right side, what's the square root of 25? 5. And remember, it's not just a positive 5, but also, because -5 squared is also 25. So really, she just solved it by square roots and solved for x. So added 6 to each side. She also got that x equals 11. And then added 6 to each side over here. She also got that x equals 1. So whose do you think is easier? Probably Jada's. The only stipulation though is what if on the right side it's not a perfect square? Like what if it's, I don't know, what if it's equal to 24? Can I still like nicely take the square root of it? No. So that's why that Jada's method kind of has a downfall. But if you notice there's perfect squares on each side, you can solve it using that method. It's just that it has to be perfect square. Questions on that? Still both a logical method, but it would have to be perfect squares on each side. So that's all I wanted to show you on this one. Questions on lesson 11? Okay, because on lesson 12, we're going to see, well, what if we do have it equal to a non-perfect square? We will show you how to make it a perfect square. That's what we call completing the square.
So I'm gonna end this video so that way I can have a fresh one.